Greetings and welcome. That's right, you are welcome to join us on this little lesson adventure regarding matrices, which, by the way, matrices is just simply plural for the word matrix. All right, matrix is singular, matrices is plural, and I will most definitely pronounce this as matrices because I find that amusing. But I find it amusing.
I'm going to ask you not to do that.
We'll see. So a matrix is a rectangular array, all right, of terms called elements. All right, so here's our little example. This is a matrix. This is matrix A. The names of matrices are often given with capital letters, just so you know. So here's our matrix, and the 1, the -7, the 4, the half. Those are all elements within the matrix, okay? Now, one of the things I want to point out, which maybe seems like poor decision making, is that matrices don't have commas between everything, all right? Those are lacking commas. No, so they don't exist, and people don't use them on that. So that's kind of weird, but that's how it goes. And it says the dimensions of a matrix. It says, let's see, the size of a matrix with m rows and n columns is m by n. That's how it's read, m by n. So question, how many rows does this have?
2.
2, right? So the rows are the horizontal, right? And how many columns does it have?
3.
Right. So 3 columns. And what I do to remember that it's the dimensions are always rows by columns, right? So the size of a matrix is rows by columns. All right, I think of this as roll call. That's my little memory sort of trick that I do, right? Like if someone's giving roll call, calling out a list for attendance. That's what I do to remember that. And you'd think that might not be significant. However, this order is very significant because matrices are very particular in the order that things are done later. So the size of this matrix, you would say this is a 3 by 2 matrix, right? Would be the dimensions, 3 by 2. All right. Another fact I wrote down is that a square matrix has the same number of rows as columns. So for instance, if I wanted...
Wait, you said it was rows by columns, so it would be 2 by 3.
Yeah, 2 by 3.
Oh, good catch. You guys saved me already. 2 by 3. Thank you, friends. You got my back.
4 by 4.
Much appreciated. Yeah, so rows, by the way, are horizontal. Columns are vertical. Columns, think about like Roman columns sort of thing, right? So 2 by 3 is the size of this matrix. Thank you, thank you. So a square matrix, if I had matrix B, would be any matrix with the same number of rows as columns. So 1, 2, 3, 0, 1, 0, 4, 2, 1, right? Something like that. This would be a square matrix of size what? 3 by 3. Because of the 1, 2, 3 rows and 1, 2, 3 columns. Okay, now it turns out there's also a way to refer to specific elements within a matrix. All right, so if I refer to, if I want to know what element is A sub 1, 1, all right, so what that's referring to is the element in matrix A in row 1, column 1.
1.
So row 1, column 1 is 1. I agree. Yep. So what would element A sub 2, 1 be?
0.
Seven.
Wait, what's the difference again? What one's column, which one's rows?
Second row, first column. Second row, first column is a half.
Oh, I thought we were on B. I was looking at B the whole time.
Oh, okay. All right. So you would have been right. Yep. So you would have been right. Yep. Well, yeah, they both happen to have the same first element.
What is it, B?
Yep. That's fine.
Oh, excellent.
So that's a half. And yeah, let's take a look at B real quick. Which one is B sub 3, 2, for instance?
You gotta be kidding me.
Which one's B 3, 2?
Number 2.
So third row, second column, right there would be the 2, right? Just so we know how to locate these. Also, this is another thing where I think commas would be very helpful right here. But for some reason they don't put commas there. So weird. They're afraid of commas apparently.
Yeah, that's 32.
Yeah, like, or it would be a real problem if I had a very large matrix and I had 3, 2, 1, and I'm like, is this 321? Is this 32, 1? Right? That would be a problem. But I don't think we ever have matrices that are that size for our purposes, so it won't be a problem for us.
I have a question.
What's up?
Am I gonna need this really?
That question is actually not often that valid within math classes because
We never use it.
oftentimes you should use your mental faculties to learn the new concept rather than trying to figure out whether or not it's valuable to you. But also, don't you worry, the Common Core State Standards have been written by business people, college professors, mathematicians, all sorts of people to determine what would be most valuable for high school graduates to know. So that's why this does happen to fit on that list. Now, as far as further explanation, if you're actually wanting to get to the root of that question, it turns out matrices can be used, guys, ladies, gentlemen, please.
I didn't say anything.
Okay, all right. Matrices, Jacob, can be used. I'm answering your question now. Matrices can be used to model all sorts of situations. Tomorrow we'll be modeling two-dimensional figures with them and be able to do translations, transformations, rotations. They also can represent multi-dimensional concepts. And as we'll see later on in this chapter, I assume you guys haven't enjoyed solving systems of 3 by 3, right? Or a system of 4 by 4 or 10 by 10 would probably not be the most fun, I imagine. It turns out matrices are actually extremely effective and powerful at solving systems of multiple dimensions. So there are values to all of that. So let's see. A zero matrix, all right, is any matrix whose elements are all 0. With all elements 0. Okay, so I could have this as a 0 matrix, so this would be a square 2 by 2 0 matrix, right? I could have a row matrix. What's the size of this matrix actually? 1 row, 4 columns, right? So it's a 1 by 4 0 matrix. This is a 2 by 2 0 matrix, right? So yeah, you can have different things like that as well. Now, here's a fact for us. It turns out, what if I tell you two matrices are equal? What do you think would be true about that? What do you think I would mean if two matrices are equal? What stipulations would be on that?
Just write this example down.
Nah, you don't have to write this down necessarily. But I'll read it. It says two matrices are equal if and only if they have the same dimensions. Okay, so I can't have a 2 by 3 equal to a 1 by 7. All right. And they have to have their corresponding elements equal. All right. So that's the idea there. So let's put this to use. Start off with this kind of problem here. So here's an example. It says, find the values of x and y for which the matrix equation is true. So first of all, what are the sizes of these matrices?
1, 2.
2 rows, 1 column, right? 2 by 1. Is this one a 2 by 1 matrix?
I don't know what that one is. It's a 1 by 2. It's 2 by 1.
It's 2 by 1, yeah. So it turns out this entire expression, 2x minus 6, is the first row, first column element for that matrix, okay? So these are the same size, and notice that I also said that their corresponding elements must be equal. So what conclusion could be drawn about their corresponding elements? What fact could you write down? What could you tell me about y? Yeah, those corresponding elements must be equal. And similarly for x, the second row first column must equal the second row first column. So x is equal to 2y. And then I could just solve something like this by substitution if I wanted, right? Hey, this one's already solved for y, so I'll plug it in. And you guys, of course, are masters of substitution. X equals 2 times 2x minus 6, so x is equal to 4x minus, whoa, 12. Yikes. No, wait a minute. Oh, right. And now I can just bring my x's together. So I've got negative 3x equals negative 12. So therefore, x must equal,
What is happening right now?
I'm solving a system
I haven't been.
based on the equations that we derived from those two equal matrices. So I find out that x is equal to 4, right? So if that's what x is equal to, how do I find out what y is equal to? Yeah, plug it back in. Right there. So,
Would you do it the other way? Did you put
Yep.
X in for the Y?
yeah, you could have plugged this into here. That's fine. Yeah, all sorts of techniques you could have used. So let's see, 2 times 4 minus 6, so y is equal to 8 minus 6, so y equals 2. Right, so based off the fact that I knew that these matrices were equal, I knew that their corresponding elements were equal, I gathered this set of facts from that, and then I was able to, solve for the variables within there. So kind of a interesting, weird, obscure problem there, but that does happen. Just so you realize that equal matrices have to be the same size and have their corresponding elements be equal. All right, so here, let's talk about what it means to add matrices. Addition and subtraction of matrices. Now, if you were the person who was kind of discovering this branch of mathematics, what's a requirement? How do you think you'd set up addition, I guess, of matrices?
Just
How
like
do
1
people
plus
even
1.
come up with these though? That's awesome.
Here, what was your statement, Jacob?
You just do like 1 plus 1. Or like 1 minus 1 equals 0.
Well, if I'm adding two matrices, what rule would you have for those matrices?
You gotta plus them.
Could I add this matrix with this matrix, do you think? No, that'd kind of be weird, right?
They have to have equal.
Yeah, they should probably have the same size, the same dimensions. Yeah. And when I add them, Kirsten and Jacob, we would probably just add them by adding the corresponding elements. And that's exactly what we did. You don't have to write this down. But yeah, so it says the sum of two m by n matrices is an m by n matrix. So I expect the answer to be the same size as the first two. And the way I find the individual elements of the answer is I just add the corresponding elements from my starting matrix, or matrices rather. So let's do an example of that, because I think an example will be easier to see.
I like making little slash marks before we start the problem.
Actually, one of the things I want to talk about matrices, notice they've been in these square brackets. All right, that's very specific. All right, it means it's a matrix. And if you don't have the little top and bottom shelf for those brackets, it would mean something different. So for instance, if I had like absolute value-ish looking bars around a matrix, that means something completely different that we'll talk about in a few days. All right, so the symbol, the notation is particular. So let's see, first of all, if I'm trying to add these two matrices, what size are they? 2 by 1, yep. Right, because 2 rows, 1 column. What size would the answer matrix be? Also 2 by 1, so I'm expecting it to be 2 by 1. And it says that I add the corresponding elements. Now, normally you wouldn't write this step. I trust that you could do this mentally, but for the sake of our notes, it might make sense for us to look at it. So this first row, first element in my answer will just be the sum of the first row, first column for each of the original. And then the second row, first column element would come from the -7 plus 5. And that's going to be how I'd calculate my answer matrix. So my answer would be 2 and -2, right? In that same arrangement, and that would be the answer matrix, right? So, that for adding and subtracting, it's kind of plain Jane. If I was subtracting, then each of these little things would be minus signs. Or another way you could subtract is by, if this was subtract, I could actually change the signs of the inside and make these all plus on the outside. But it doesn't matter. Adding and subtracting is not too crazy, I don't think. Not at all. Let's see. Today we're having a nice kind of easy day in the realm of matrices. Actually, I don't want to do an example yet. I want to talk about scalar multiplication. Oh, the last concept today, and then yeah, we got one example after it. But I'm not even going to have you write down the explanation. I'm gonna show it to you and then explain it, and then we'll do an example together. All right. So first of all, what do I mean by scalar? A scalar is a number, so it is not a matrix. All right. It is a single number that I'm going to multiply by the matrix. No. So it says a scalar is a number, the product of a scalar k, so some number, and an m by n matrix. So this is a whole bunch of elements, and a scalar is just some number. All right. Is an m by n matrix denoted by k times a. All right. So if my scalar was 2, and I wanted to multiply the matrix by 2, I would just write 2a or 2b or whatever the matrix name was. Each element of Ka equals k times the corresponding element of A. So let's do an example of this real quick. Not too difficult here. And this is what we'll have. So here's a matrix multiplied by 3. All right, so 3 is the scalar. All right, so that's my scalar. S-C-A-L-A-R. And what I do when I multiply this matrix by that scalar, it's going to be the same exact size. Actually, what size is this matrix? 3 by 2. 3 rows, 2 columns. Yep. And the way I would calculate this is I would just multiply each element by 3. It's kind of like a distributive property. So for the sake of our notes, we might as well write down what that would look like, even though you could just do that math in your head on the homework and quizzes and tests and whatnot. So let's see, 3 times 5 and 3 times -4. So I'm expecting my answer to be exactly the same size. And I would have, 6, 3, -3, 9, 15, and -12. All right, so that would be my answer. Notice, once again, I'm using this little square bracket for my box and for the showing the way the matrix is arranged, so that notation is specific to matrices. But if I wanted to box my answer, I'd actually have to end up, kind of putting a box around that square brackets in order to make that make sense. What's your question?
Do you simplify it if you can?
Yeah, I guess if those had fractions on the inside or something, I would simplify it. Also, I want to point out that notice like this, if I wrote those two close together, that could look like 15 minus 12. And because matrices don't use commas, that sort of mistake could happen. So you'll want to make sure that you have kind of a nice little space between your columns so as to avoid that possibility.
You can't simplify those at all, because 3 goes into all of them.
What do you mean simplify?
Obviously, 3 goes into all of them.
Yeah, but like.
You multiply that by 3.
Well, hey, yeah, that's true.
Oh,
If
yeah.
we reduce
All right.
them, it would just be the original answer.
I guess
Did you just hear that?
I'm trying to figure out what you mean by reduce them.
Never
It
mind.
looks like
So-
we're going to divide them all by 3 because they're
Oh.
divisible by 3, but we just
Just
multiply
Right.
that by
didn't
3,
even
which is
divide
the original
it.
problem.
So-
okay.
So
Oh
now,
my God. I feel
each
so
of these
stupid.
elements. No, it's fine. Each of these elements, don't think of this as some sort of weird fraction or something. Each of these elements are their own independent, unique number. All right? So if one of those elements was a fraction, all right, so say one of these elements was 3/12, then yes, I should simplify that. Okay? But don't think of trying to simplify these in respect to one another because they're elements, they're friends, but they are not related beyond that. All right, so this number and this number, they just happen to be neighbors, but I wouldn't simplify them somehow within each other. All right, so that's the idea for matrices for today. Hopefully this stuff makes sense. Tomorrow is going to be the more challenging lesson. But it's okay. We'll survive. Bye-bye.